Hello students, welcome back. Previously we went through an example on supply and demand. Actually we went through two examples. We went through a theory and then a trivial example when the model is explicitly there, setting these two equal to each other and solving. What is P, what is Q? You can get those because we have two unknowns and two equations. Now this one is a little bit more realistic because we have to get the model. What's the model? It's right here. So we're doing linear models. In general, these can be nonlinear, but this is 1000 level, so linear models only. So linear, MQ plus R form, I could have selected other characters. And then again, MQ plus R form, one for supply side and one for demand side. And then here, demand side information. From here, plug in the values, and then you get two equations to find out M and R. And blue, that's the supply side. Plug in the values, and you're going to get two equations to solve for M and R. And once you get all those, now you can go ahead and set them equal to each other and solve for P and Q. So basically you're solving three systems of linear equations. Okay, now let's go one step further. Suppose further the wholesalers are taxed $14 per unit. Find a new equilibrium point. So we are considering the taxation as well. So one thing you can think of is this wholesalers are taxed. So the tax is going to the demand, to the consumers, and the consumer wants to pass it on to the supplier, basically. So the price is kind of like increasing in the supply side. Am I making sense? Basically, it's this. Supply side. So previously we had this. We have this. And the demand side, we had this. And then price increase of $14 must be passed on from wholesalers, which is demand, to the manufacturer. So plus 14 applies to the side, to the supply side. Am I making sense? At least that's the way our textbook explained. Now, if you accept why this is plus 14, not this one down there, if you accept that, the solution is easy from this point on. Setting these equal to each other, 2Q plus 170 plus 14 is 184 instead. And then that's the demand side. And solving that equation, let's see, 85 plus 27Q, and 450 minus 184 is 266. Dividing by 7, you're going to get 38. And plugging in 38 to either the first or second, you're going to get the price, 260. So once you accept this plus 14, it is taxed to the demand side. So it is passed on to the other side. If you accept that, then this is not too difficult. Now, do you accept it? That's a big question. Anyway, that's the way our textbook explained, and I'm actually a little bit disappointed because why in the world this plus 14 is passed on to the other side? That part was not explained very well in our textbook. So let me try something alternative. So tax is being put into the wholesalers, okay, the demand. Okay, this is very typical case, as a matter of fact. Let's consider not just dryers, but something that's really hot these days in international trade. For example, computer chips. Suppliers are coming from South Korea or Taiwan, the two biggest manufacturers of computer chips, the high-tech computer chips in the world these days. And then U.S. manufacturers are actually trying to buy those. Now, U.S. companies are demand. In that case, the tax is put to the buyers, to U.S. companies only, because you see, Korean government and then Taiwanese government will not tax their export because they want more export. U.S. government, on the other hand, tax it because they do not like to import too much, and so taxation is usually onto the demand only. In international trade, it's almost always like that. And in case of consumer market, that too. Tax is put onto consumers, and sales tax and local tax, all those are coming to consumers. So this is not really a strange, outrageous model. This actually makes sense. The linear model may not make much sense, but taxation on demand side only, that actually makes a lot of sense. Now, okay, accept that. So at least compared with the textbook's explanation, it was a bit verbose, but at least it made a bit more sense. Now, the key part. The wholesalers, the demand is willing to pay the same price as before, whether there's no tax or tax. But the price will not go to suppliers. I mean, not all of them will go to suppliers. Some of them will go to suppliers, but a part of it, $14 to be precise, then go to state, go to U.S. government. So what's happening here? Demand, the money that the consumer pays, is separated into the money that supplier gets plus the state, the U.S. government. Does this make sense? The money you pay as consumer, is total amount you pay, but not all of them goes to the seller. Part of it goes to the seller, and another part goes to the taxman. That goes to the government. So the demand is supply plus tax. Okay? Price the consumer pays is the price tag plus tax. Does it make sense now? So instead of going back to the model and adjusting the function, keep the same function, but separate this payment into the money that goes to the merchant plus tax. If you look at it in terms of consumer, if you look at it in terms of wholesaler, the money wholesaler pays goes partly to the supplier overseas in, say, South Korea or Taiwan, plus the tax you pay to U.S. government. Okay, now it's easy. DFQ, this one, that's red. This one here. We did this -5Q plus 450 in the previous video. And this one, the supply side, you see. And then plus tax. Okay, now solve it. It's easy now. Just some algebra. Turns out 38. Plug in and you have the price. So there are two ways. One is somehow if you have taxed one party, it has to be passed on to the other. Why? It's hard to explain, but that's the way it is. And then go ahead and solve it. Why not plus 14 here? Because after all, taxes paid to the wholesaler, to the demand. Why pass it over to here? That part is a bit unclear. Now the alternative way, do not change the model, same model. But the money wholesaler pay is separated into the price tag for the supplier plus tax, so that the equation is previous model and then plus 14 here, and then result into the same answer as before. So, do you want to change the model, or do you want to keep the model and then change the equation? Depending upon what you do, well, depending upon what you want, you can choose whatever you want to do. Me, I prefer to do it in the second way, but our textbook author, of course, disagrees.